they drew the center of the moon, which is also the sun. You know what I mean. They're the same size. And what they did was they drew another circle here from here around, and you can see that doesn't quite. It's just a little bit of this is sticking out on each end. At least it should. And what happens is when they did that, they found out that the Earth, which is this one, this is the Earth, and this was a square. They considered that a square. And this is the circle that goes around the middle of the sun or the middle of the Earth, which squares the circle. That means that the distance if I run around here is 44 miles. If I run around this square, it's also 44 miles. That's heaven and earth together. That's how they figured this out. So what did the Egyptians do? They did something with their pyramids that is just fantastic. They made this the ground. Of course, that's the center of the earth. And what they did was that, okay, if this is the earth, then I'm not going to make the triangle go up to earth. I'm going to make it go up to the moon. And that's how they did their triangle, or how they did their pyramid, which is fantastic because they brought earth and heaven together. Here it is. Here's the triangle. Here's the pyramid. There's a circle that goes around that. And then they put heaven on top. And there it is. There's the height of the pyramid. And you can see the little corners that don't match up. The little guys that stick out here. That's because this is the earth and this is heaven. Okay, and they brought earth to heaven. It's a fantastic idea that they came up with. And that's how the height of the pyramids were determined. Heaven and earth. The squaring the circle. So, one of the things I wanted to show you here is that the Vesica, okay, which I drew on the board before, that's root 3. And it's two circles. The center becomes the periphery. And that distance right there is always root 3. So you can always draw that. Next thing I wanted to show you is how they used the Vesica throughout history. They always put a god of some type or a very high being in the Vesica. Why? Because the Vesica is the balance between heaven and earth. When those two come together, those two circles come together, one is heaven and one is earth. And right in the middle, root 3, is the form that they always put into these Vesicas. And these are, throughout history, they're used, even today. And of course here it is in nature. This is from the Hubble telescope. There's the Vesica. I don't know how well you can see that, but there are actually two. There's one around here too. But this is found in what we can't see, but it's there. Here it is three-dimensionally. So here's, you can see that something's happening out there, okay, in the Vesica, which is three-dimensional. There are two spheres that are coming together. Look at that. What is going on? Now, if you think about this drawing that I first did with the Vesica that shows the middle of the earth, the core, and the Vesica around it, the Vesica is really two spheres. Maybe there is some connection into this. I really don't like to take questions, but what is it?
Oh, I guess I'm not sure what two spheres that's representing.
Yes, it's hard to see. Start with this. You know, even in the books, the science people don't know those are really spheres. They just see this. Anyway, they never talk about it anyway. See, here it is here. There's a sphere, and then there's another one right here. Can you see that? This sphere is like this. So that shows you that how the Vesica is used. And then, of course, the Egyptians, like I drew, used this same thing. Okay? They used the 3, 4, 5, which is the moon, the earth, and then the combination of those two, or the sun and the moon, the square is a circle. Okay. In the past, even Stonehenge, how many thousands of years ago, was working with squaring the circle. So the inner and the outer. And here's the way it works. Here's 3, which is the moon. Here's 4, which is the earth. And 5, which is the sun. And here's a bigger view of that. So you can see what these different sizes are. There's supposed to be a 4 right there. So anyway, if you always find that there's the 4, which is the earth, the outer one from the 4 is always the sun, and the inner one is always the moon. So here's how they did it, the Egyptians. Like I showed you, here are these little corners that stick out with a sphere over it. And here's the sun, and here's the earth. Okay, so here comes the Byzantines. They come along and they say, well, we want to do that. We want to put that together. So what they did is they took a cube and they put a sphere on top. So this is heaven and this is earth. But they kind of got lazy, because it's difficult. I mean, this isn't, the circle is the same size as the square, okay? But it's the idea that they were after. So here's another picture of it. Here they rounded the corners off. But they're still after heaven and earth. Let's see what's next here. No, that's a kind of a not a very good picture of what I just showed you. And then here we go with the Egyptians, and then Islamic people and their constructions. What the Egyptians or what the Greeks did is interesting. They took earth, and instead of using the circle, they used another cube. And that's the proportion of this distance. 2 cubes. So if you remember about the Greeks temple, okay, was where the god entered the earth and stayed in the temple. So that makes sense that the god also becomes earth, becomes a cube. And it's all based on 5, root 5. So we know that this is root 2. This is why it's so neat. You know that it's 1 here, root 2, root 3, root 4 makes a square, and then root 5. And look at this is what root 5 is. It's amazing that this is root 5. It's so simple. That line perfectly is root 5. It's another number that you can't measure. That's root 5. And the distance from here to here is what root? 7. This is fantastic, isn't it? All made from the cube. Okay, so what the Islamic people did was they had the square. If you take the diagonal of root 2, which is here, and you swing it down, that's one part of their building. Then they take the next one, which is root 3, and swing it down. So here's root 3, root 2, and the square. This is how these buildings were designed. And even at the top, here's the square. Here is root 2. That's the size of their dome. Same here with the square. And they just ran it over here, which is root 2, and they just swung an arc from here to here. And that's how they designed their buildings, because what they're doing is working with the cube, okay, earth, and heaven. Now, you notice that this bows out a little bit. See how that bows out? And you've seen these in these churches, where they kind of bow out like this on the side. The reason they bow it out on the side, because that circle becomes the size of squaring the circle, whereas this one isn't. So what the Islamic people did was they say, wait a minute, this is no more effort here. We have to make our buildings like this. And now the circle and the square are equal. Again, this is a real quick way of looking at architecture, but I'm trying to encourage you, if you're interested, to go into it deeper and deeper because of all these styles and evolution of architecture. I'm making it really fast. Because what I'm trying to show is that there is sacred ideas behind that and using sacred numbers, and that's why it's sacred. And that's why they're making these buildings sacred. Okay, so let's see if I can catch us up here. What's next? All right, there it is. That's how the Islamic people work that out. You'll see these in Greek, so forth. And here, look at this guy here. This is the one. This is the Kabbalah. This is the one that everybody goes to once in their lifetime, right? And it's the cube. It's absolutely nothing but the cube. So you're asking, well, where's the heaven then? How'd they get away with heaven? Yeah, that's right. All these people going around in a circle. And that makes the heaven part. That's bringing heaven and earth together. The people, and if you ever notice how, or see a picture of this, they circle in the spin of the earth. So that's cool too. Okay, here we come to Chartres Cathedral. Now this is the ultimate Gothic building ever. It is perfect, if you know what I mean. I mean, as far as Gothic architecture. And remember, the Gothic, how does this have anything to do with sacredness? Because it's just flat, and I don't know if you can see it from there, but I'll show you where it is. I just so happen to have this drawing here, so it's too bad it's not straight up and down. But if I run this straight across here, that's 1. This is root 3. And if you connect these right here, it makes perfect 2 equilateral triangles. And if you look at this whole thing is 2 equilateral triangles that centers in the center of the building. And if you can look at the Visaka. So they went really right after it. They went right into the 2 circles, and they got their equilateral triangles, which is so hard to draw, but yet it's so easy. And what they did is they, in the very center here, there's a cube. And here's a reproduction of their floor plan for Chartres. And notice there's a red cross, and then it has an upright of blue. And in all the books, they cannot figure out how come this is a different distance than this. And so a lot of them have drawn circles in there, and they say this is 28, and this is 56, and 7 times 8 is 56, and 6 times whatever. But that's really too much. That's too complex. It's much simpler than that. Okay. All you have to do, and it's not in the books, and the only reason I did it is because I was interested in this. If you take a hexagram, which is a cube, right? You saw how this works into a cube? Everybody saw that? Well, I got it right here. It's easy to show. Here's the hexagram, right? Here's the true triangles. That's root 3. Same as I drew here. The same that is here. Here are the triangles here. 1 here. Well, let me show you here. This is root 3. And why is it called formative forces? Because all you have to do is take that form and stretch it up to the top of formative forces, and it turns into a perfect cube. That's why it's called formative forces. Because this doesn't happen with root 2, but it happens with root 3. Okay, so if you take that hexagram and you put it on here, it tells you exactly why there are those 2 differences. You don't have to figure anything out. It's right there.